Welcome to Relative class. This is physics lesson. We shall be looking at momentum, grade 12. We're talking about momentum of a force. Before the start of the lesson, we are going to make rules and regulations which be consistent to the school rule. So group 1 here, group 2 there, group 3 and group 4. 4 in each group. Be in a group. Now, rule 1, we all know before you say anything, put up your hand. I'll call you, say your mind. If you want to answer a question, you do that. If you want to go out, you do that. You don't make noise. And if you have any concern, you draw my attention by raising up your hand. Thank you so much. Now, we have objective of the lesson. We have only 3 objectives here. First, by the end of the lesson, the student should be able to define momentum of a body. 2, state the principle of conservation of momentum. And 3, solve problems related to colliding bodies. Now, we know that every object has mass. And when it has mass and it moves, it has velocity. So, what is the value of its momentum? Let's take an example. If this is 2 mass, 2 body, it has a mass. So when it moves, we say it undergoes momentum. It undergoes velocity. It has certain velocity when it moves. So if the same object with a mass undergoes velocity, we call it momentum in physics, in science. Meaning the object is moving with certain momentum which has a mass, and the product of mass is velocity. If 2 objects are moving and eventually they collide, 2 objects are moving and they collide, now 2 things happen. After collision, either they move together with the same velocity, or after collision they stick together. So 2 objects moving, they collide. After collision, what happens? They get mangled, they stick together, they move. We call it inelastic collision. And when they collide and they move at different directions, we call it elastic collision, because their momentum and kinetic energy is still conserved. Now, let's see some demonstration. We have another different body. When they meet at certain top speed, 2 objects moving at different momentum, when they collide, they stick together, this elastic collision. They meet and they move different direction in elastic collision. So let's look at an example on a board. So we said momentum is the product of mass and velocity of a body. And let me use M to represent this. This is mass, this is velocity. The SI units will be kilogram meters per second. That is for that. Now, what do we say is the principle of conservation of momentum? We demonstrate that. To demonstrate this, if in a collision, when 2 objects collide, a condition no external force is applied, we can say they maintain their same velocity, they maintain their same energy, or their energy or the same momentum. We say we call it principle of conservation of momentum. We say that in a system of colliding body, so the principle of conservation of momentum states that in a system of colliding bodies where no external force acts on the object, the total momentum of the body remains constant. Now, we demonstrated that when two objects collide, and when they move with the same energy, the same momentum, which means that they maintain their velocity, their momentum and energy. So in this way, we form a conservation of kinetic energy and momentum. So we call it principle of conservation of momentum. Let's solve some questions regarding to momentum. Let's look at two bodies. When body A move, body A of mass 1, body B of mass 2. When they move with initial velocity, and body A move and collide with body B, if the object move at different if they move in different direction, we call it elastic collision. M1, M2, and they have their final velocity here, M1 and M2. Which means that when they move in different velocity, their momentum and kinetic energy is conserved. We call it elastic collision. Mathematically, this is an example of elastic collision. Let's look at inelastic collision. Under inelastic collision, both bodies move with the same velocity. Momentum before collision momentum after collision. Before collision is here, after collision, they get mangled, they stick together, they move with the same velocity. So elastic and elastic collision, this is, and we take the kinetic energy of this body, we say half. So this is elastic, this is inelastic. In a nutshell, when two objects come together and they have collide, head-on collision, this is how to calculate their respective masses and their velocities. Now let's take a problem, let's solve a problem on this and see how to go about it. Kilogram mass object travels at 6 meters per second and collided with an object with 9 meters per second. 9 kilogram, also moving in the same direction. If both bodies move with 33 meters per second and 2 meters per second, respectively in the same direction, calculate the velocity of the second object. Move with this body A, move with 12 meters. So I demonstrate physics, I sketch in all my calculation to have visual impression of the whole question. So body A moves and they move in the same direction. Same direction. So body A, so it's 12 kilogram the mass, M1 is here, at 6 meters per second, U1, collided with another of an object weight 9 kilogram, moving in the same direction. We don't know this. If both bodies move with 3 meters and 2 meters. So after collision, Three meters and 2 meters, their respective velocities. Calculate the velocity of the second body. Simple. It's so simple. Solve this. This is elastic collision M1U1 plus M2U2 will give us M1V1 plus M2V2. So we substitute 12 multiplied by 6 plus 9 root 2, 12 times 3 here. So 9 times 6 will give us 72 plus this. This will give us 36. U2 will give us 2 meters per second. To subtract it from the divided by 9, you get 2 meters per. So, in a nutshell, we calculated it, we got this. So this is how to find momentum of a colliding body when two bodies collide. In a nutshell, we talk about what is momentum, principle of conservation of momentum, and we solve problem relation to momentum. So, class, when we meet again, we shall solve more questions related to momentum where we shall go deep into other concepts. Thank you so much. Bye-bye.